Circular shapes is not a new concept. We've been covering these formulas for a while. The first one is on your formula sheet, but you probably don't need it on there, and that's the circumference of a circle. Remember, we can use 2 pi r or pi d, whichever is more convenient. So I'm not going to do an example of that one. The next one, though, the arc length of a circle, we're going to look at an example of that. So the arc length is where you just have one section of the circle that we're trying to calculate the distance of. We need to know what angle it would form at the centre of the circle. Okay, so this arc length here, this is a curly L, so this is L. And this angle at the centre is theta. Now, we've always done things like half a circle, we just do a half times 2 pi r. A quarter of a circle, we do a quarter 2 pi r. What we want to be able to do is any fraction of a circle. So we know that the full circle is 360 degrees. So the fraction of the circle that I have is the angle I'm given over 360, just multiplied by the circumference. So that's where the formula comes from. It's a really simple concept. So for example, if I had an arc here,
What about Noah's Ark?
nothing to do with Noah's Ark, okay? If I had an angle here of 37 degrees, and I knew the radius was 6.2 centimetres, then I could calculate the perimeter of this shape by using the arc length. So the arc length rule here would give me L equals 37 on 360. It's doing this weird shadowing thing on the board, kind of looks weird. Times 2 times pi, it's like a special effect, times 6.2. That is going to give me the arc length. So it's 37 over 360 times 2 times pi. Got that? Times 6.2. So that's going to give me the arc length. Now for this question, it's a bit silly, but normally I keep a couple of decimal places more than I want in my answer. So if I want my answer correct to 1 decimal place, generally in my working I keep 3 or 4 decimal places. So there's a couple of zeros there, so it's a bit pointless, but let's say we're going to keep 3, so it'd be 4.004, because remember I asked you to calculate the perimeter, so I'm not at my final answer yet. So the perimeter is all the way around the edge. So my perimeter is going to be 6.2, then the 4.004, then the 6.2. So 6.2 twice, plus 4.004. So we're going to add to that 6.2 twice, which is 6 to 1 decimal place, is 16.4 centimetres. Was everyone happy with arc length? Okay, the trickiest type of question is they could maybe tell you the arc length, and then you had to solve the equation to find theta or r. So if I told you the arc length was 10 centimetres, the radius was 3, you could rearrange this equation and solve for theta. Okay, so that's about as tricky as it can get. Alright, now also on your formula sheet is some area rules. Now we've seen the area of a circle quite a few times, okay, pi r squared, nothing new there. Area of a sector is also not particularly new, it just means you've got a fraction of the circle. So whether it's a half or some weird angle, just doing that fraction multiplied by the circle. But this one, annulus, is new, okay? So an annulus is a new concept, but it's a pretty simple concept, okay? So an annulus is concentric circles. Does anyone remember what the word concentric circles means? What's concentric? Concentric. No? Okay, so concentric circles are circles that share the same centre. Okay? So an annulus is 2 concentric circles. I think I put way too many letters in there. Yeah, that's a bit of a spelling issue there. Now, Ben. that would look like this. And what you're looking for is this area in here. It's like a donut, a very flat donut. So if I was looking for the area of this donut and I didn't have this rule, can you tell me what you would do? So we don't have this annulus rule, I'm told you to find this area. What would you need to know and how would you do it?
You need to know the radius of the whole circle.
Radius of the whole circle, yep.
All the way.
I'd need to know that. Yep.
We need to know the radius from the centre to the middle circle.
I also need to know that distance there, yep.
And you need to know.
And then what am I going to do? So
That's it.
that's all you need to know. How do I calculate the area then?
Pi squared
The big one minus the little one.
Big one minus the little one. Yep. Big circle minus little circle, so pi r squared minus pi r squared. To make it clear when we're doing pi r squared minus pi r squared, we call the big circle with a capital R and the small circle with a small r. Okay, so the area would be the big circle, which is pi times the big radius squared, minus a little circle, which is pi times the little radius squared. That's this formula here. Okay, so all they've done is they've factorized and put pi out the front, and that's the formula. So it's not really that exciting a formula, is it? It's not really that new, because you already knew that without me telling you, okay? You already knew big circle minus little circle. So it's not exactly very exciting. But that rule is on your formula sheet, okay? So this is straight off the formula sheet you have in front of you and you'll have in the test. Those three rules are there. Now we can combine them and do a sector of an annulus. So for example, oops, let's go back. Say I had something that looked like this. And I'm trying to find this area here. So that is a section. So I've taken the annulus, and instead of taking the whole annulus, I just want part of it. So I'm going to need to know extra information. I need to know the angle of center. We're going to say this one is 43 degrees. I need to know the radius of this bit that's been cut away. So I'm going to say that's 12 centimetres. And I'm going to say that this bit here is 7 centimetres. So I want the area of this annulus. What do you think I should put at the front? What's the first thing I should write down? I'm trying to calculate this area.
43. Over 360.
Right? Yes, who said 43 over 360? Well done. We need to know what fraction of the full annulus we have. So the first thing we're going to write down is the fraction, which would be that we have 43 3/60ths of the annulus. Okay? Now we're going to do an annulus, so we want big circle minus little circle. So we're going to put a pi next. Then we're going to do big radius minus small radius. What is the radius of the large circle here? Which is 19, because that's whole distance is 19. And the radius of the small circle? 12. From the centre to the small circle is 12. I grab a calculator, I type it in. 43 on 360 times pi times 19 squared. Oops. Squared. And we get, to one decimal place, 81.4. Now the units are area, so it's centimetres squared. Okay? Any questions about that? Alright, your turn to start the exercise, 303.